Okay, everybody's clicked the got it. So I will convene the meeting of the solid waste management subgroup. This is the diversion, reduce, reuse, and recycle subgroup. Good morning, everyone. I'm playing a little bit of a substitute here. As we all know, our state Senate co-chair of the Environment Committee has segued into another chairmanship. So at this point, just helping out here and letting this meeting go on. Kind of, like I said, being a substitute here. And without further ado, I don't see any of my other co-chairs in the room. So we are going to go right to Brian Paganini for his presentation. Brian, when you are ready, the floor is yours.
Thank you, Representative Gresco, and obviously our lifesaver Gaia for getting us set up today. So thank you very much. I've been asked today to talk a little bit about anaerobic digestion, specifically around food waste diversion. Obviously, food waste within the context of the overall makeup of our trash stream is roughly 22% of what we throw away here in the state of Connecticut. And food waste is unfortunately the least recycled part of that waste stream. So today we're going to touch on a couple topics. One being the diversion aspects of anaerobic digestion, a little bit about the technology, and then some why behind the interest in anaerobic digestion technology, and some potential optionality for the state of Connecticut moving forward. So a little bit about our background here and my background at Quantum. So Quantum Biopower is the state's largest commercial food waste anaerobic digester. We process roughly 40,000 tons of food waste annually here on this campus. We share this campus with our sister company, Supreme Forest Products, which is a green waste recycling facility located in Southington, Connecticut, in between Lake Compounds and ESPN located in Bristol. So in totality, we operate on roughly a 50-acre campus. The digester itself, as you can see in the left-hand part of your screen, occupies roughly a 4-acre footprint. And this campus essentially takes in food waste products and green waste products. We use our know-how and our technology to convert those products into molecules of energy or products of value such as compost, bark mulches, and topsoils, which is generally purchased within the tri-state area. Specifically with Quantum, we are processing a variety of waste streams at this plant. We process pre-consumer food waste, manufacturing waste streams from beverage companies or cheese manufacturers. We take in a lot of packaged waste goods at this facility, materials that are expired, off spec, or mislabeled, that really don't want to end up in landfill. We can depackage and process those materials, harvesting in a lot of cases the packaging for sale back into the recyclables market, and then harvesting out the food waste, which obviously goes to the anaerobic digester. We also take in municipal food waste, which is green bag waste, and there's been obviously a lot of interest in that here in the state of Connecticut with the advent of the pilot programs. Under natural conditions, we are fermenting those food waste streams. You can see the large tank in the backdrop of the picture. That tank, if you're familiar with the beer beverage manufacturing process, we're essentially fermenting large volumes of food waste, creating methane, and using that methane as a gas to power an electrical generator. No different than on a generator that might be at your house, except we're not using propane or natural gas to run our generator to make electricity. We're using the methane that we've created from this fermentation process on our campus. Over the course of the year, because we're recycling food waste and not letting that methane get into the atmosphere, we're avoiding roughly 5,000 tons of atmospheric CO2 and producing roughly 8,000 tons of compost from the residual materials left over after the process. And to give you kind of more of a specific look at what we produce here, so we take in a lot of different forms of food waste as we suggested. We're fermenting those food waste streams. The energy we make really at its base is biogas, which is about 62% methane. That 62% methane goes into an engine that's the size of a shipping container, and we're making electricity, but also we're making hot water. We're making thermal energy as well. So essentially, we're taking the heat from the exhaust system of our generator and repurposing that heat back into different parts of our process. And we're using that heat to heat a lot of our buildings in and around the digester that are on our campus. If we were to not produce electricity, we could produce renewable natural gas, which requires us to upgrade our methane one step further. And in doing so, we would produce roughly 100 million cubic feet of renewable natural gas. And for those of you who are not familiar with RNG, RNG is a more environmentally friendly form of natural gas. We're not using sophisticated fracking technologies in the shales that are in eastern Pennsylvania to get our gas. We're actually using food waste to make our gas, and therefore in doing so, it's a more environmentally desirable gas, and therefore has a much better carbon intensity and is a desirable fuel for folks who are needing to decarbonize the amount of fuel they use, whether you're an academic center, a commercial facility, or a utility itself. As I said before, we make compost from our residual products. So we take a lot of the material that's left over from the digestion process. We blend that with ingredients, with wood waste ingredients that are on our campus. And we produce a phenomenal compost that last year, actually 2 years ago, we bagged and sold that into the marketplace to indoor growers, residents, commercial users, and some other third-party fertilizer companies within the tri-state. Focusing a little bit more on the art of processing food waste streams, Quantum has built pretty robust processes that can take in a variety of food waste streams. We actually have a depackaging center on our campus, and this is really critical to anaerobic digester technologies is the way you're treating the streams of waste coming into your facility and your system to make sure that you aren't fouling your downstream equipment and you're creating homogenized streams of waste that can be easily digested. In our case, we have a series of buildings, and those buildings have technology to depackage, decase, process these materials. And you can see at the bottom of your screen, we're taking in a large variety of materials: meats, produce, fish, vegetables. These come in bags, these come in packaging, these come in multiple layers of boxes. But in totality, we're processing those waste streams, getting the food waste out, bringing that to the digester, and at the same time, we're recovering the things of value, right? So that's PET plastic, that's aluminum, there's cardboard off-spec materials. We're getting all those materials out, and we're able to be able to lessen the footprint or lessen the disposal footprint of facilities like ours by bringing that material back into the recycling marketplace. The material that we create is very clean and therefore is a very high-grade recyclable. Focusing a little bit more on the compost side and talking specifically about our process, we make about 20 yards of leftover material from our digester daily. That material is combined with other woody waste materials on our facility campus. We're creating compost, we're bagging those blends, and also it's nice that we have such wonderful academic support within the borders of our state, because there's some wonderful opportunities for alignment between companies like ours and the agronomy labs, such as the one at Southern, to help us study the efficacy and the viability of the compost materials that we make. So it's not just Quantum saying that these compost materials work very well. These materials are tested and they're rigorously proven. So as we go to the marketplace and say, hey, we've got some wonderful materials, those materials are well vetted and well tested within an academic setting. So transitioning a little bit into the why behind diversion of food waste, and this won't be a mystery to this group, but I think it's important to really mention the why behind diversion, particularly in a state like Connecticut. When you look at Connecticut as a whole, Connecticut is the most dependent state on energy from waste facilities, incineration facilities, really in the Northeast. As you can see, we have the most capacity of energy from waste facilities per person of population here in the state. And that's not too dissimilar to Massachusetts and New York, but Connecticut especially is really dependent upon incineration. So when we see these, as we've seen in previous years, energy contracts going from $300 per megawatt down to $40 per megawatt over time, putting a strain on the incineration system, obviously we see the impact of that with rising disposal rates. So this has been a very public occurrence that has happened in our state, and everyone is very well aware of this. But as a result, what has happened is it's forced states to consider diversion of food waste. And obviously, Connecticut was one of those states back in 2011 that led the challenge, or that led the way in diverting more food waste streams from its state. Now our diversion program is ratcheted down to a half a ton of production per week within a 20-mile radius. And of course, the challenges that we faced on the trash side are not unique to Connecticut. And what that has caused is it's caused other states in the Northeast, in a lot of cases, most of the Northeastern states, not all, but most, to implement and to enforce some sort of a food waste diversion mandate. Again, trying to focus on the largest portion of the waste stream that's the least recycled in an effort to try to stem the increase of disposal costs, but also to try to let some pressure out of the capacity to balloon within the Northeastern states. In our case, we look at the state diversion mandate here in Connecticut, and what we know is that 22% of the waste stream is food waste. We've got about 2.5 million tons of MSW here in the state of Connecticut. Quantum is built to handle 40,000 tons of the 500,000 tons of food waste here in the state. But of those 40,000 tons that we're able to process, only about 15% of those tons of food waste come within the 20-mile radius around Quantum. So said another way, there's a lot of commercial enterprises within our diversion radius that are yet to divert their food waste, segregate it, and get it into our facility. And really, what that simply is it's a symptom of proper incentivization or proper regulation around the diversion mandate. So we put this slide up to demonstrate that in principle, diversion mandates are good. It's good to raise awareness. But in practicality, they don't drive the amount of food waste tonnage that folks or one might believe they do when in application for facilities like ours. What is, however, driving a lot of diversion and program awareness are ES&G goals, which are largely being used to shape corporate policy. So I'll give an example. 92% of the S&P 500 companies now have sustainability missions and targets. This is up from 15% just 20 years ago. So most of the companies that lay claim to Fortune 500 status in the state of Connecticut have some sort of recycling, diversion, or waste management sustainability action plans built into their mission statements. This is driving a lot of the interest, particularly in our world, in diverting food waste from the companies that actually manage food waste in large volumes. Buttress that with, back in March, the Securities and Exchange Commission proposed rule amendments that will require publicly traded companies to disclose their climate-related data. So said another way, if you operate a public company and if this SEC rule takes shape and takes hold, then that company will be mandated to really identify their scope 1, scope 2, and scope 3 emissions, which further drives this public and commercial sort of endeavor around diverting more of their materials out of their waste stream. Because now when the SEC says you've got to do it, that's more of a have to do versus a nice to do. On the other side of the coin, what we see in our world is decarbonized fuels and decarbonizing transportation is driving a lot of the interest, particularly around anaerobic digestion and renewable natural gas. So similarly, companies are seeking to decarbonize their fuel use, whether that's operating on-site electrical generation systems that don't want to be dependent upon traditional natural gas anymore, but dependent on more decarbonized gases like what we produce here at Quantum, such as renewable natural gas. Couple that with fleet natural gas. Obviously, logistically speaking, there's a lot of groups out there now who are considering upgrading their fleets. There's a couple of folks here in Connecticut in the hauling world that have upgraded their fleets to natural gas. It's not too far in the future where a lot of these fleets can now operate on renewable natural gas and further decarbonize the way that they're using their gas in their systems. So what we say here at Quantum is we believe it's time for a more comprehensive food diversion policy. Clearly stated, mandatory diversion sends a clear message to folks who are in this space wanting to develop more facilities. And what's critical to projects like ours is shoring up the waste streams to make sure they're as repetitive and essentially guaranteed fuel tonnage coming into processes like ours. It's the only way for groups like ours to get the capital excited enough to invest in projects that are really capitally intensive and essentially large infrastructure projects. California passed a similar bill called Senate Bill 1383 a couple of years ago, which required mandatory diversion of food waste within counties, navigating away from landfills and recycling facilities towards more food recovery sort of infrastructure. And they buttressed that with establishing a $250 million financing granting mechanism in order to support future infrastructure here within their state borders. Now, this might not be the model that Connecticut pursues, but I am articulating this to say that there are different avenues and different ways to pursue food diversion in a more regulated and a more comprehensive fashion. What we look at here in Connecticut is the ways to currently essentially remove food waste from the waste stream, and the market is shaping up in such that we have a lot of pilot programs that have been initiated relative to co-collection. There are a lot of ways to get food waste out of the waste stream. One of those ways is transfer station side separation, physically using mechanized processes to scrub organics out of the waste stream. What we do know about these processes is that they are very effective in getting organics out, but there's questionability around the use of those leftover wet waste streams that have a high content of organic fraction in them, and their permissibility in digestion and their permissibility in being used in post-digestion, i.e. compost sort of products. Obviously, we know about curbside collection, adding a third container to the curb, and essentially putting out another route to go and collect curbside collected organics. This adds cost to the model, but we do know that the quality of those organics could be higher. I think that's yet to be determined. We see this in other countries, certainly not here in the U.S.'s culture at this stage to be implementing broad brush curbside collection programs, but we do see through some of the pilot programs here in the state that certain curbside collection programs are being implemented, but they're mostly being implemented in a co-collection fashion. So co-collection essentially is we're taking food scraps, putting them in a green bag. That green bag is going into a trash can. That trash can is being collected by the hauler, and then those green bags are being sorted out at the transfer station. I will say that having firsthand experience with these organics, this program is in its fledgling stage. There's a high level of contamination currently in these sorts of food waste streams coming in, but I know that the groups who are involved are actively trying to educate the citizenry to make sure that the food waste that goes into these bags is cleaned up and is more consumable for folks on our end of the post collections and processing spectrum. So finally, some thoughts about the future of digestion in a state like Connecticut. What we believe is that it'd be great to revise the solid waste management plan and send a very clear regulatory signal to the marketplace, right? And I say that in the sense that if we want to recover organics through mechanized processes, then there have to be some certain messages and signals sent to groups like ours in the way we process, treat, and create usable products at the back end of digesters. I think that's really critical for us to understand. It'd be great to establish incentives for companies wanting to invest in recycling infrastructure, such as power purchase agreements, RECs, carbon offset measures. The concept of intermediate processing and really leveraging the wonderful network of transfer stations we have here in the state of Connecticut, and incentivizing those folks to put in diversion equipment and technology to be able to cleave more organics through a mechanized process out of the waste stream. I think it's a time that we got serious about food diversion mandates. We either need to enforce or incentivize those mandates. I think we've done a great job with our current diversion programs of raising awareness and education. And now I think Connecticut's poised to take the next step. And then finally, supporting economic systems that put financial value of food diversion back into the folks who are creating waste at the home front. We like to call it the HSA model. No one is a better protector of their own dollar than themselves. And the HSA model for health insurance seems to be an effective way to look at what could be the future of waste management here in the state of Connecticut. So, and then last but not least, there's a lot of opportunity for digestion in states like ours. However, groups like ours need to get a clear line of sight on where that next volume of food waste is going to come from in order to unleash that capital. But we're very encouraged that the state is taking those necessary means through pilot programs. And I think there's going to be a lot of good learnings coming out from this recent launch of pilot initiatives for us to, to make some really hard decisions down the path here. So with that, I'm going to stop talking. If anyone's got any questions, happy to field those questions, but I do deeply appreciate the time.
Thank you, Brian. While everyone thinks of their questions, I'm going to rattle off a couple here. So are you saying that Quantum itself has the ability and has capacity to take on more going forward, like the scenario you explained of, let's say, everybody within that 20, hopefully soon to be 40-mile radius was to comply, you would have the capacity to handle that?
We do have the capacity for more organics within our facility, particularly around the organics that would be generated from frankly municipally generated organics, which tend to be lower strength, sort of more dilute materials. We have a lot of capacity for those sorts of materials. And the one thing we did right at this facility is we permitted extra capacity at this plant. However, we're built for a certain threshold of capacity and throughputs. We are permitted to take more. And the beauty of facilities like these and many other digesters is a lot of this is sort of a rector set technology where we can add tankage and add additional capacity as volumes grow.
So thank you. Next to, excuse my ignorance, but so you have the hookup there, the electric line hookup that feeds right into the grid from Quantum, right there on scene. And then there was no issue getting permit with that.
So yeah, that was a little bit tricky, mostly because we have to obviously approach the utility to seek an interconnection agreement. That was about a 13-month process. And essentially what happens is the utility analyzes the amount of power you're going to produce. They work with our engineering team and their engineering team to design electrical systems to be able to take that power. And then it has to go through an approval process. So it is not a simple process. But we were able to navigate it, and ultimately the power we produce on this campus gets fed through underground duct banks into a point of common coupling that is basically a handshake between us and the utility, and our electrons get put onto Eversource's grid system outside of our front gate.
And then my last question is, from what I understand, there are existing approved permits that are just waiting for, for lack of a better term, a consistent feedstock, as you were referring. I don't want you to tip your hand, but is Quantum one of those?
So Quantum does have plans for expansion here in the state of Connecticut and in other surrounding states. You're right, there are permits that are either expired or nearing expiration. Yeah, I won't sugarcoat it. It is very challenging to develop projects like this. There are a lot of nuances and tentacles to these projects, and in order to get the full faith and support of folks in the capital space, a lot of details have to be, well identified and articulated. And I think that was probably the benefit, to being a local group. We were able to do that. We will be looking at other infrastructure here in the state. I can't say if it will be within those permitted areas, but we do see ourselves in the Fairfield County area and looking at some infrastructure down that way to satisfy, some of the population density in that part of our state.
Happy to hear you say that. That's enough for me. Monopolizing. We're going to go to James Alvis from Deep next, and then if anyone else has any questions, please raise your hand.
Thank you, Mr. Chairman. And Brian, thank you very much for the presentation. On your last slide, you mentioned something about the HSA model for citizens. Can you explain further about what you meant by that?
Sure. So, the way I like to commonly describe it is, I have a bit of a biotech background, and we know a little bit about HSAs around here. So, you know, when you have $5 in your pocket, you're more likely to spend those $5 wisely because they're your own $5 versus someone else's $5, right? So the HSA model we look at is, and we don't profess to know the system or the financial remuneration system that could avail itself here, but you know, imagining a waste system whereby citizens get the benefit or feel the benefit financially of diverting their food waste out of their containers and bringing it to facilities that are capable of recycling it, right? Those are the sort of, you know, those are the instruments of really good diversion that we see in other parts of the world that seemingly have phenomenal capture of organics, really well run, you know, tiered systems and structures over time. But again, looking at the unique nature of our, more frankly, in the Northeast, of the systems that we have here, we like to point to things that say, hey, if there's a way to remunerate and compensate folks for doing good, for diverting food, then we think that's in the best interest of the state to consider those ways and means.
Gotcha. And you talked a little bit also about the quality of the feedstock that you need for your facility. I'm wondering if you could get into a little more detail about that, and in particular, how it relates to the you know, residential source separated streams that we're starting to see more of.
Yeah, it's a great question. So Quantum is built to take a large variety of really any type of food waste, and we could take a banana peel and an orange and a piece of meat and a loaf of bread and use those substrates and turn them into digestible fractions, right? Where programs and processes like ours start to get a little derailed is where we get high levels of contamination. Contamination, you know, there's a difference between incidental contamination, which is a plastic knife or a fork or, you know, a produce sticker or wrapper, and then there's substantial contamination, which is pneumatic tools, things that are more akin to municipal solid waste versus traditional forms of food waste. So we always like to tell our customers, we're okay with incidental contamination. You know, we don't really advertise that too overtly, but obviously incidental contamination happens with tried and true diverted food waste streams. But once we start to navigate into contamination that is more akin to MSW thresholds of contamination, then we have to look at some re-education or ways of sort of cleaning those streams up. And in the context of these pilot programs, James, we've seen kind of all across the board. We've seen really good specs of food waste that are low levels of contamination, some incidental contaminants, and we've seen the opposite end of spectrum, which is high levels of contamination, which has triggered us to go back to the groups that are leading these diversion efforts and say, hey, time for a re-education step, time for some conversations, because look, it's not going to be perfect out of the gate, and we know it's going to take time to grow those programs. But really what we are is we're kind of the leading indicator back to municipalities saying, here's what we saw, here's what we evaluated. Our lab does a great job of assigning sort of these, subjective outlooks on these loads coming in. And we like to provide feedback back to these, these groups coming in and the towns coming in to say, hey, here's what we saw, and here's what we think you need to do to clean up those streams down the road.
Got it. Thank you for that. And I think what I heard you kind of explain is that the high quality feedstock is important both for your process on site, but also for the viability of the byproduct from your process and being able to use that as compost. Is that fair to say? Yeah,
it's very well said. And I'd even extrapolate that comment across all waste energy platforms, right? It's really important to get good inbound feed to any system, whether that's a thermal system or a biological system. Good clean feed means that your process runs well, and that if you are a process like ours that reuses the residual byproducts, those products are kept intact and are market ready.
Great. Thank you, Brian. Thank you, Mr. Chairman.
Sure.
Thank you, James. And I could speak as the chair of the Environment Committee, and that we look forward to Deep coming in and letting us know what they have planned as far as food diversion in the legislative session going forward. And then if you forgive me before we get to Frank, I have one more question, more from the, I guess, get your hands dirty, for lack of a better term. if I was, someone interested in myself taking my food scraps out of my personal home's waste system and waiting a couple of weeks, and if I'm close to Southington, driving up there and saying, "Here you go, Brian," and then
Yep.
why? And then you take walk-ups, for lack of a better term, and then if I'm there, can I buy a bag of compost that you produce there? I'm just trying to get a
Sure.
handle on a day-to-day reality kind of for crazies like me.
Yeah, no, it's a great question. We do take walk-ups. You'd be surprised at the amount of folks that drive up in their cars and drop off a 5-gallon pail of food waste. And while they're here, they take a bag of compost or bark mulch. So we take, there's no minimum volume, there's no maximal volume here at Quantum. Being a new facility in a state that is really trying to embrace food diversion, we try to be very accommodating to all comers, and that means big, small, or indifferent. So yes, we take a lot of smaller waste streams, and we're happy to do it.
I think I have my 2023 New Year's resolution.
There you go. There you go.
There you go. All right. Thank you, Brian. Next, we're going to go to Frank Antonacci. Frank.
Thank you, Chairman, and thank you, Brian. I just want to commend Brian and his group for building Quantum and getting it off the ground. And I think, as Brian alluded to, these projects are not easy, and they are not overnight success. So I appreciate his stick-to-itness and as he continues to develop these projects. My question would be, as you said, these are erector set type projects, and you have available capacity. What is the gating factor that today keeps you from being able to build that next module at Quantum or at another site? And
Sure.
What maybe limits these other permitted facilities to opening?
It's a great question, Frank, and thank you for that accolade and recognition of the team. I deeply appreciate that. But I think it's a great question, right? The primary gating factor is getting a clear line of sight on the next tranche. And when I say tranche, the next 20, 30, 40,000 tons of food waste and where that's going to come from, right? Because the ripple effect of that is it affects the way you design these facilities. It affects the way you design the recovery systems for these facilities for wastewater and for compost. But most importantly, because these are capitally intensive projects, right? The next facility that will be built will be a $40 or $50 million project. It's really the driving force behind the majority of the revenue stream associated with getting the capital stack in place to get the financing in place to build more projects. So it really stops and starts with the ability to track down and to locate the food waste tons that are going to come into plants like this. It's the gating factor for us to expand Quantum here physically in Southington, but also it's what we're aggressively pursuing in other parts of the state and other parts of the tri-state.
Thank you. And I guess maybe one follow-up question, if I may.
Sure.
So you gave like three types of generation systems: transfer station, mechanical separation, I think the 3-cart system, and the co-collection system. I don't want to put words in your mouth, but I'm sure you'll take the organics whatever way it comes, and would encourage all three. Which of those three do you believe have the ability to generate the highest quantity quickest? Yep.
Yeah, so you're right. We'll take all three. There's no silver bullet, but the highest quantity, the quickest, is definitely mechanized separation at the transfer station. Again, all things being equal in the ability to reuse soils and digest, quickest generation happens in the current system we're operating, which is transfer station separation for sure.
Thank you.
Sure.
Thank you, Frank. And before we move on to Kai's, and Jen has a question, but let me just finish here. What would the effect be on Quantum if, let's say, one of the other permits they decided to build, and it was kind of on the other side of the state, but not really, and maybe within the soon to be 40-mile radius. What does competition do for you? Does it dilute the feedstock?
So in a malformed market center, and I'll explain it this way, it could dilute the feedstock, but what it will do is it'll also bring out of the waste stream feedstocks that are currently not coming to Quantum, right? And the only example we have of this is the waste energy space, right? The reason why we don't have incinerators built right next door to one another, because we have a determination of need status here in the state of Connecticut, right? So when you file permits, the department, the DEP, we assess whether or not we should be building incinerators in towns next to each other. Obviously, this I'm referencing years ago, and mostly because we want to build capacity where capacity is needed. Because we don't have a really tried and true food diversion regulation, those food waste streams are very malformed. So pointing back to one of my slides earlier, only a small fraction of food waste comes from the 20 miles around our plant. Most of it comes from 40 miles to 250 miles away from our facility. So to answer your question, stands to reason that depending on where other facilities are built, and there's other facilities out there that we're essentially going after the same food waste streams for, it could dilute those streams, but also on the flip side, it could encourage more diversion within that locale, within that magic 20 miles around that facility as well.
Thank you, Brian. Now we're going to go to Jen Eaton-Jones. Jen, thank you.
Thank you, Representative Gresco. So my question, it might actually touch a little bit with Frank and a little bit with Brian. So the question at hand was mechanical versus commingle to get to the higher quantity, but then what about the quality? So, I think I'm trying to think about how I'm going to organize my thoughts here. So with a commingle system, a bagged system, I can see that sort of addresses the need for the easy and convenient for the resident, maybe not as easy and convenient as just putting it in your household trash and then later being mechanically separated. But it also still addresses perhaps the need for efficiency for the collection for haulers. Again, maybe not as much as it just being in your household trash and then mechanically separated, but my concern would be quality of the material. And when we're talking about mechanical recycling of organics, that's basically, nobody likes this word, the dirty MRF system. And what about things like cat litter? How would the system identify the difference between organic food waste and food scrap and other organics versus things like cat litter? Mm-hmm. And then your end product being a product that you're selling to the community for compost that they're using in their gardens. What happens to the quality?
Yeah, so this is the $64,000 question, Jen, that you hit on, right? While we can get more volume out of the waste stream through mechanical sortation, what do the quality of those organics look like on the far end? And the way I'll answer it is that there has to be more processes and more detail, through different thermal treatment steps to be able to sequester kind of the bad stuff in those streams to make those usable products. And I will say that there isn't a consistent regulatory sort of point or opinion on the usability of those products, both here in the US or overseas in markets that have defined composting regulations like Italy, Germany, and the UK. So, pointing back to one of my comments earlier, if we do decide to go down the mechanized sortation route, in order for folks like us to digest those materials, we'd have to have some pretty, robust conversations with the DEP to say, okay, here's how we think those materials should be, treated and used, and here's what our idea is for reuse of those materials in the long run. because it's really unclear to us. This isn't a Connecticut thing. This is more of a, you know, of a global problem. How do you reuse those materials? Because at this stage, they're not really reused in compost. They're reused as roadway dressing. They're reused in aggregates. They're reused in other means and products that are not you know, apportioned to growing food. You know, that might get it back into the into the food system. Does that make sense?
Yes, and I appreciate that, right? It would be used for a different, it would be marked for a different end use.
Right.
So just to wrap up my thoughts here, and then going back to the mechanical separation versus commingle, and maybe this is a question even for Frank, when we're looking at municipalities at cost of end disposal, although mixing our organics in with as a single stream of municipal solid waste, and it then later being mechanically separated versus commingle, there's still a cost. So there's a cost to separate it mechanically. So that would increase our tip fees. Even if we commingle, there's a cost at the transfer station to separate those commingled bags. What is more efficient and cost effective for long-term financial sustainability for municipalities? Did you answer that?
You want me to answer, Jen, or Frank?
Someone, either.
Yeah, you know, so the mechanized systems that are on the market now, there's a first cost and there's an associated, you know, operational cost over time. You know, those are real costs. I'll definitely let Frank, you know, talk to the MSW side of things. But you know, those have to be factored in to short and long-term sort of disposal, because they're not insignificant, you know, and they are additive in the process. So for us, it's actually 4 or 5 process steps, quite frankly, that you're adding to a system to get, you know, those organics to a place where they can be digested. And then not mentioning, you know, the reuse on the back end, what the systems that you have to deploy in order to make those, you know, those usable.
Yeah, so I think I appreciate your question, Jen, and I think this is a productive discussion. I mean, I think because this highlights the fact that we are at the front edge of these types of systems, technologies, where we want to go with this, and we have to be having more of these types of conversations as it evolves.
Right.
You know, there's costs to all this, as you said, Jen. I mean, there's no way around that. There's no free lunch. You know, the way we're thinking about it is we shouldn't be ruling out one system to the other. And what we're seeing in our counterparts and some of my colleagues that I speak to on the West Coast in California, they're seeing robust co-collection and 3-cart systems that they're still having to add mechanical separation because they're getting such high levels of contamination in them. So what I've said is let's learn from what we see going on in California, because if we're in essence processing MSW that we're calling organics, then maybe it'd be more cost effective, more efficient, and actually generate more usable organics and energy from those organics in state by just eliminating that step. I just don't think we could patently dismiss that.
Okay.
Not a concern in regards to perhaps the way that we've moved with single stream. There are pros and cons of single stream, where we had a collection system once upon a time where it was source separated with some contamination. Now we have single stream with high contamination. I see a similar parallel with we begin to source separate our organics and then decide, oh, let's just single stream it because we're mechanically separating it anyway. But yet you might still have a higher quality byproduct or feedstock for the fact that it's still source separated but has some contamination. So those are the things that I'm concerned about, is looking for an easy, convenient, efficient system that doesn't give you a high quality end product that ends up being used for something else rather than what we need as compost to help our soil. So those are just my thoughts. It's like I'm looking for not just how do we as municipalities look towards source separation to reduce solid waste and get a good a system of reducing that, but yet at the same time, how do we move towards a good quality system as well for the end product? So thanks for your time, Representative Gress.
Thank you, Jen. Thank you, Brian, and of course, Frank. We're going to move on now to our next individual, which is Fort Hill Farms. Kais, take it away.
Hi, my name is Kais or Levac. I am from Fort Hill Farms here in Thompson, and our partner in our digester is Fort Hill AgGrid or AgGrid Energy. They're out of Pennsylvania, is the main company. Rashi Aki is the founder, CEO, and her son Abu Aki is on the call here, and he is going to screen share for the presentation. We also have Andrew in, and the two of them, I'm here to talk, to answer as many questions as I can, but I thought it was a good idea to have them sit in as they know more of the company as a whole than I do. I can talk about our company, but I figured I'll let them talk first, and then if you have any questions for a dairy farmer, I'm here to help. And if you have any questions on our digester, so I'll turn the table over to Abu and let him take it away.
All right. Yeah. Thanks, Kais. I appreciate it. And thank you, Representative Gresco, for organizing us and having us out here today. And thanks, Brian, for kind of priming our audience here and answering the hard questions. I appreciate it, making my job a little bit easier. One of the, I think one of the distinctions between us and Quantum's facility is just the fact that we co-digest. You know, so Fort Hill AgGrid is a special purpose entity formed between Fort Hill Farms of Thompson, Connecticut, and AgGrid Energy in Kennett Square, Pennsylvania. And what our joint purpose is to, you know, number one, encourage dairy farm sustainability. So we like working with, you know, smaller farms like Kais, like Fort Hill Farms, to help provide additional revenue stream and improve, you know, dairy farm sustainability across the board for these types of facilities. So Fort Hill AgGrid has been in operation since January of 2021, and here I'll run through, give you a little bit of an overview of our site here. So this portion right here, if you can see my screen, please let me know. This site right here, or this portion right here, is the actual digester. So we have about 90-foot diameter round digester tank, 20 feet deep. So you're only seeing the top 1 or 2 feet right there. And we process both the manure that comes from the dairy as well as food waste, pre-consumer food waste. So we're talking about things like ice cream waste, or fats, oils, and greases. You know, those sorts of materials and feedstocks are primarily what we accept at this facility. And we commingle those. And what we find is that the manure provides some sort of, I guess, buffer for us as a food waste itself can often, you know, produce a lot of gas. That manure provides a steady output of gas for us. So right here are our food waste and manure influent tanks. We also produce electricity out of this digester system. So we take the biogas, we send it through an H2S scrubber into an engine where we convert that biogas, which is again that CO2 and methane, into renewable electricity and send that directly onto the grid. Now, the further integration here with, which is unique to this dairy as well, is the solid separation piece. So what's left of what we call digestate, which is that final product that comes out of the digester, actually goes through into this building, up onto the second floor through screw presses. And so what we do is we're able to take that digestate and squeeze out some solids out of that, about 30 to 40% solid content. And we're able to build up those solids here, if you can see that, under that building. And what we're able to do with that is use that as, back on the farm, as animal bedding for the actual cows. And then the remaining liquid digestate is then fed into this lagoon, this covered lagoon. So all of the digestate is actually underneath that tarp that you see there. So Fort Hales Farms, again, located in Thompson, Connecticut, has got over 1,000 acres and a crop production base of approximately 600 acres, and 400 acres are forest managed with a sustainable harvesting program. So overall, we have around 500 animals on this facility. So we're able to take the manure from those 500 animals, which is approximately 13,000 tons per year that we're able to extract from those animals. And then additionally, we introduced that food waste, which this facility has the potential to flow around 24,000 gallons per day, or 40,000 tons per year. And again, that's of that liquid slurry. So just to give you, here's a better process flow diagram as well. So we have three primary inputs, and we consider them three because we do we try and separate our low organic content from our high organic content organic stream. So of course, number one, we have our dairy manure that is going into the digester, but then we have two separate pits, and we have in the first pit what we call a low organic content, or a low BOD or COD. And then in our second pit, we have a higher COD, and we're able to basically meter in those varying strengths of food waste to adjust our gas production to be able to optimize our engine output. And we find that it's much easier to manage the digester and keep the digester happy. And then beyond that, of course, we're going to be generating electricity from the biogas going through the engine, and we're actually able to recycle the heat. So the thing about these digesters is that they need to be kept at a certain temperature. So our digester, we target around 100 degrees or so, and the waste heat that comes off of the engines is sent to a heat exchanger, and the water, the hot water, is used to keep the digester at 100 degrees. So we're not bringing in outside electricity or outside natural gas or propane to actually heat the digester. And then from there, the electricity goes to the grid. And as I mentioned before, the digestate, the liquid stream, goes to a solid separator, and the solid portion is used for animal bedding, and the liquid portion out of that is then used as fertilizer on the croplands, just as farmers would use with their raw manure if they didn't have a digester. And this slide is a little bit busy, but what I really want to just highlight is this solid separator right here. So as we had shown before, on the second floor, we've got the solid separator screw press that then drops these separated solids out here onto a pad that we're able to just take and put into the barns. So this facility is Connecticut's first farm-based anaerobic digester producing electricity. And again, as I said, we have been operational since January of 2021, and we've been able to work very closely with Kai's and her husband Jared to operate this facility. And it's definitely been a learning experience. And you know, this is Agrid's third facility, so you know, we've got a few projects under our belt, but there's always new information and new things you learn with every facility because every project is different. But the facility includes, again, the actual digester, manure and food reception tank, a digester storage tank, solid separation unit, as well as the engine interconnection, and then a safety flare as well. In the event that our engine is down or we need to perform maintenance, we're able to send the biogas safely at a safe distance away from the facility and send it out to the atmosphere. This is just a further overview, bird's eye view of the project as well. Again, digester, this breaks down our influent tanks, our effluent tank for the manure, and then our food waste tanks, our influent food waste tanks, where trucks will come in and pump the actual slurry into there. So overall, since we started up in 2021, Fort Hill Aggregate has been able to divert a good amount of waste. So we've processed 9 million gallons of food waste roughly over the past 2 years. And we've been able to produce 4.3 million kW, million kilowatt hours over the past 2 years as well. And those kilowatt hours have been, we've been able to take advantage of the virtual net metering program through Eversource. And those kilowatts are being provided to the city of Middletown as well as the city of New Britain. And we do have some plans for expansion out here at this facility. We're looking to, potentially, of course, accept additional food waste and generate more electricity off of this facility, as we do have some room for expansion and room for growth, as well as being able to align ourselves with Connecticut's needs as well. In addition to that, we're also developing our fourth digester facility, which should be operational by the end of this quarter out in Coventry, Connecticut at High Tone Farms. So we hope to continue to be able to offset and divert food waste away from landfills and incinerators. And that's all I've got, short and sweet. Any questions, be happy to field those now.
Thank you for the presentation. I have a question right out of the gate. You potentially answered part of this at the end here, but I'm hoping the bill we passed recently out of the Environment Committee was helpful, is helpful. The fact that you're talking about expansion and the capacity to expand at the current location, and also the follow-up in Coventry. So I guess talking amongst your peers, is this going to be happening on more farms than just the additional Coventry going forward, I'm hoping?
In the state of Connecticut, I think that's something we are assessing. The nature of these projects, as well as, again, we said our mission is to help small dairy farms and encourage dairy farm sustainability. One option that we've been exploring in other states as well is, especially if we're not getting enough manure from one dairy. For example, you might have a dairy that only has 90 cows, right? Which not only limits the amount of material you have, but it also limits the amount of food waste you can bring on site as well, since we are held to a certain ratio, right? And at that point, we have to decide, if it's financially viable or not to be able to justify a project, especially with the way the economy is going right now, just with increased capital costs, increased cost of materials, it's difficult. But one of the things that we're excited about, and one of the things that we're trying out specifically in California and in Michigan as well, is the idea of a community digester. So that is a centralized location utilizing several dairies that in a close proximity and centralizing that manure and then using that facility as a center point for food waste as well.
Thank you for that answer. There's a punchline in there somewhere about potential feedstock at the Capitol for you, but I'll let you insert that punchline as you see fit individually. Does anyone have any other questions? Johanna, please.
Hi, thank you for the presentation. I was wondering what size of farm do you need for this to be a viable business relationship? And then with your work in other states, what is Connecticut doing right and what should Connecticut be doing better?
Sure. It really depends. These projects depend on so many different factors. There's of course permitting, which Connecticut has been really instrumental in allowing us to build these projects and have been incredibly helpful. There is just there's electricity pricing, which now at an all-time high is making some of these projects definitely look more favorable for us as well. I don't know if we necessarily have a minimum. I would say, in Massachusetts, for example, our smallest project, we have about 180 cows. So if that gives you some perspective, we were able to justify that as well. But that is also incorporating food waste. I know manure-only digesters for those size dairies are not feasible. So the food waste is truly an integral part to our business model and to what we do in making these projects viable. As far as Connecticut goes, I think Frank brought it up earlier. What we're seeing in California is so different from the way it's done out here in the Northeast, in Connecticut, Massachusetts, and New York. The onus is put on the municipalities rather than the generators, right? And I think that's a key difference in what Connecticut is doing and how they're enforcing some of this food waste diversion. So, we're definitely able to take advantage of those pre-consumer facilities, like ice cream waste and those generating fats, oils, and greases from, everywhere from your local McDonald's to large manufacturing facilities. That is definitely a benefit. I think, one of the things that actually Rashi and I were talking about today, that is making it somewhat difficult to secure some food waste, as well as just the hauling size of vehicles. I don't know if that is under your purview. I don't know if Kais has anything else to add to that, but just the hauling size of these vehicles, I think it's 6,000 gallons in Connecticut, right? Whereas in other states, it's 8,000 or 9,000, especially with the growing cost of fuel, the growing costs associated with that, and where we are in the economy, really, it's making it less attractive to haul smaller loads of material.
I agree with Abu. It is, we are on the Mass Rhode Island border and taking in loads. If the weight limit of a food truck could be increased so that we could take those loads from Massachusetts and Rhode Island, they have higher weights. And people would love to come here, but they don't want to get in trouble. And I don't blame them, because I don't want to get in trouble either, so the motivation is there. It's just they don't want to come this way because of the limit. And they being on the border of the tri-state area, we have the option to be able to take those loads, but it limits us to what we can do.
and it makes it difficult to haul it long distances from other areas of the state as well. You know, if there's, you know, if we're talking about 100 miles or so, you know, obviously we're not going to be sourcing food waste from that far away, but it definitely disincentivizes some folks, and it disincentivizes us as well, not being able to haul that, you know, something like 8,000 gallons.
Sorry.
All right. Any other questions?
Because I don't want to forget that. My apologies. Thank you. Next, we're going to go to James Albus, followed by Frank Antonacci.
Thank you,
And
Mr. Chairman.
before we go on, I think you should stay away from talking about ice cream waste, especially with a fat guy here. There is no such thing. Thank you.
I'll just be sending it to your house then.
Well, thank you, Mr. Chairman. Abu, thank you very much for the presentation. Very, very interesting what you guys are doing at Fort Hill. I know you gave some tonnage numbers, but or gallon numbers, but curious, you know, in terms of what percentage of what you're taking in is currently food waste, whether it be the pre-consumer or FOGs.
Sorry, your question was what the volume is?
What the percentage of the total amount of waste that's going into the digester is in terms of food waste?
That's a good question. I should know that off the top of my head, but I don't.
What was your question?
But what the total percentage of food waste going into the digester is?
So our total percentage of food waste is 100,000 gallons. That's a weekly.
That's the total.
That's what we take in for food waste from the various companies.
And how does that compare to what's going in from the on-farm waste?
That I did not get that part from my husband.
It's
So,
approximately
I'm not-
12,000 gallons.
To give you an idea of what we can process, so I think it's more.
Yes.
We have like 13,000 tons of manure annually is what we project for, and then about 37,000 tons of food waste. So I would say about a third of it is right. Am I doing that math right? Or I guess a fourth of it is going to be manure.
Gotcha. And in terms of the food waste, particularly the pre-consumer waste, do you know where that was going before these generators kind of entered agreements with the AD facility to send it to you guys? Do you have any idea how they were disposing of it?
That's a good question. I don't, that's a good question because I don't think, those pre-consumer waste can go to landfills. They're too, I think anything below 20% solids is not really going to landfills. Is kind of the rule of thumb that we use. I'm not sure, honestly. I mean, I know that in some states, they allow land application. New York specifically allows land application. So I don't know if that material was being hauled as far as out there. Guys, do you have any idea, or Andrew?
Am I on mute? No. Okay. Sorry.
No,
I didn't know if I was on mute. No. So I am not. As to my knowledge, I don't know where that food waste was going to before. The companies vary in so many different companies that we take in that I don't know where each company was taking their food waste to before us. And for manure from the dairy farm, it's 50,000 gallons per week.
Gotcha. And one last question. So the digestate that's produced, is 100% of that being used on site, or is some of it going elsewhere for use?
Completely on our own site.
Great.
We have, Abu had showed you where the lagoon is, and that lagoon is all the food waste and manure mixed in together. That the closer that's up high, that's the lagoon.
Mhm.
That lagoon has the leftover from the digester, which is food waste and manure. And that then is applied to the fields 2 to 3 times a year. We empty that. And that is applied through injection. It's a applicator on our equipment, and it injects it into the ground. So it's not, we're trying to prevent runoff. And actually we have found with this, we have our crops are growing better than they were before.
That's great. Well, again, thank you for answering the questions and for all the great work you're doing. So appreciate it. Thank you, Mr. Chairman.
Thank you.
Thank you, James. Next, we're going to go to Frank Antonacci, followed by Brian.
Yeah, thank you, Chairman, and thank you to the Fort Hill team. These on-farm digesters are really a great, another example of a tool in the tool chest here to attack food waste, and also solve for on-farm disposal. So it's nice to see the proliferation of them continuing in the state. I think it should, serve as a demonstration to all of us that, again, there's a multifaceted approach here when we attack food waste. And for those pristine, I believe, organics that you're taking that are mostly liquid, this is a fantastic application that works hand in glove. And I think it illustrates that potentially as we go down the stream to smaller quantities and different generators, we're going to have to take different approaches. So I appreciate you sharing your success and best of luck as you move forward. As a question on, I believe what you were alluding to at the end of your presentation is the weight limits in the state of Connecticut. Is that accurate? Being at 80,000 pounds versus 100,000 pounds in our neighbors?
Mm-hmm.
So that is probably multiplied for an industry like yours, as milk is an exempt product from the 80,000 weight limit. So you're used to shipping at 100,000 pounds. Is that accurate? So yeah, we in the recycling industry, we deal with the same issues because we are handling commodities that cube out before weighting out, or weight out before cubing out, and it's something that we do support as well, and would be happy that you brought that up here, especially when you're dealing with dense products. During COVID, the state did grant us an exemption to be able to ship at 100,000 pounds. Which I think is a good thing that maybe this working group can take as a takeaway here to advocate for that as well, again, to promote recycling and organic recycling as well. Because to talk to Jen's point before, if you're able to ship at a higher weight, what does that do for your cost structure?
I mean, it more so it incentivizes other folks to really even consider our facility, to consider bringing material to our facility as well, I think.
Thank you.
Thank you, Frank. And now we're going to head over to Brian to wrap it up. Brian?
Yeah, thank you very much, Chairman. And again, congrats to the Fort Hill team. It's a great project. Particularly what I like about this project is the alignment between a group like Agrid and Fort Hill Farms, and showing how the technology side and engineering side can marry well with an operating business, because obviously the farm wants to maintain their core business, but yet there's an opportunity here to sharing some resources and generate some more value for the farm. So it's an awesome project. I hope we see more of the farm system being built in the state to really preserve the agricultural footprint in the state of Connecticut. So it's super critical. My question is not really a question, but more of an interest and inquiry around what Keith was alluding to before, which is the digestate reuse back on the fields. I'm curious if the team has examined any potential savings from traditional fertilizers, considering the fertilizer market is upside down and sideways, by reusing a lot of your lagoon digestate back on the fields. Is there, and I don't have to know the savings, but is there a large market of savings, any savings? I'm just curious if that's been additive to the project.
Yeah, it's definitely something we've considered. I don't know if we've talked about it necessarily at Fort Hill, since generally we've been able to handle all of the additional digestate that's generated from bringing food waste on site, right? And that's one thing that we have to really heavily consider and weigh as we're developing these projects, is really how much material can we bring, can we accept on site, because that material's got to go somewhere at some point too. And if we have a farmer who doesn't have the acreage to handle it, then that's a bridge we have to cross, and that's something we have to talk about. But in that, taking that into consideration, and those discussions have definitely led to those ancillary projects on the back end of our digesters. We haven't necessarily run any numbers on them. We've definitely thought about it, and we've definitely, we're definitely having conversations about it, because I think that there's definitely a huge potential to also help some of these farming communities as well, and provide some of that fertilizer at a rate that's not so astronomically high. So yeah, that's definitely something we're thinking about, but it would be a second phase or a third phase of some of our digester projects.
That's great. No, again, thank you for the presentation. Send our best to Rashi, and thanks for your time today.
Will do. Thank you.
I just have one thing to, sorry.
No, go ahead.
So I agree. Thank you for having us. This is very important, and we appreciate meeting you all. One thing I just want to add is, if anybody is interested in a tour here on the farm, please let me know. We're always, happy to give a tour out to anyone. We are also adding on to the farm here. We have a robotic barn we are adding on. And we hope to be in there by springtime. So the cow will walk in, and the arm will come under her, clean her udder, and milk her, and she can walk right out. And I might have a little bit more free time on my hands. So, come this summer when it warms up, hopefully. If you guys are interested in a tour, please reach out to Abu, Andrew, Rashi, or myself, and we'll get you a tour of the farm.
Thank you, guys. Don't head out yet. Jen has a question before we head out.
Yep. Sorry. Yep.
Sorry, can you hear me?
I think you're muted. Oh,
Sorry.
yeah,
I just want to, not a question, want to go on the record. I echo Frank's comments. I would hope that this group, as we are here to talk about how we can improve solid waste management in the state of Connecticut, it is critical for us to come together to consider and how we can advocate for increasing the weight limits for solid waste and recycling in the state. It should be considered as one of the solutions as we move forward in presenting solutions for the entire state. So I just want to go on the record that we as municipalities support that as well.
Yeah, well, I was having the same thoughts as you were, Jen, and writing my notes, and I think I would be safe to say that we have at least a friendly, sympathetic ear in the new Senate chair of the Transportation Committee, which I think this is going to have to go through, but it's already on my to-do list going forward. So thank you, everybody, for taking the time to educate us here today. I don't know, and if you had to press me on it, I don't think this group will meet again during the 2023 session. But please feel free, each of the individuals here, to reach out to me and also my Senate co-chair Rick Lopes with concerns and questions as we go forward. And while we're here, don't forget on Thursday we'll have my subcommittee meeting at 10 o'clock. And again, thank you all for